Hi, in this video I'm going to be explaining how I did L systems in Blender geometry nodes because there are a few people that seem confused by some of the things that I did when I was trying to show it. So to give a quick overview here of what an L system is, I'm assuming you're a little bit familiar, but basically what it is it's a series of strings, or one big string, a series of characters. Each one is a command. So this capital F means you move forward, the minus sign means you rotate to the right, the plus sign means you rotate to the left, and so on. There's a bunch of symbols it gives in the book here. And this book is The Algorithmic Beauty of Plants, which is available free online, and it's a very good book. And then the next part of an L system is you have an initial state here, a premise, and then you apply these rules. And so this particular example here, you go forward, turn to the right, forward, turn to the right, forward, turn to the right, forward, and then you're back to where you started, and it just makes a square. But if you apply these rules, so every time you have an F, then you substitute it in with all of this. And then you do that here and here and here, and then you can do that again iteratively to replace all of the new F's with those. And if you do that with this example, you start out with this square, and then you get this shape here, you get this shape and this shape, so you can generate these kind of fractal curves, which is pretty cool. And so let's jump into Blender. And I am using Blender 4.0, and that is because it has the repeat zone, which is, I think, kind of necessary for doing stuff like this. So I recommend you either get the alpha version of Blender 4.0, or maybe Blender 4.0 is already released when you're watching this. So let's go right into it. This is just the default scene here with just our cube. We actually don't need that geometry input. And I just want to think a little bit about what do we need. So obviously we need some strings. We need our initial premise. We need a rule, and I find it easier, rather than trying to do string parsing, I'm just going to name these rule 1L and rule 1R, and so there's an implicit equal sign in here. And we can add more rules later, but for right now all we need is one. And then we need a position to track our current position, and then we need a direction to track our current direction. And I think that's enough that we can get started right away. Oh, we also, one more thing. We need to know the number of iterations to apply our rule. Okay, so applying the rule is actually very simple. We just start, let me back up a second here. Okay, what we're going to do is try to do the example that we just saw on the screen, which was this. And then we had F minus F plus F plus FF minus F minus F plus F. Okay. And our angle, oh, we need our angle too. That's the last thing. And that can be a float. And I'll name that angle. Okay, so the angle is 90 degrees on that. And I'm going to say, for this example, let's start by forward direction is just going straight up along the z-axis. And we'll start with no iterations. Oh, this should be the right side, and then this should be F. So how you read this is F equals this. And with that, it's actually quite simple. There's a function called replace string. And all we need to do is find what's in our left here and replace it with what's in the right. And we have done our whole replacement right there. That's how you do a rule. And then what we can do is with the repeat zone, oops, wrong one. You actually don't need the geometry input of the repeat zone at all. So we take this here and we plug that in, just like that. And then we can apply our iterations here, and it will replace our rules as many times as we want. And that's all there is to the replacement. If you want to add more rules, you just add more replace string nodes and you add more inputs over here, and that's it. And then what we need to actually interpret all the commands and place all the geometry on the screen, we need another repeat zone, and we plug our premise in, and what we're going to do is take each one of the symbols in this string and kind of take off the first symbol and pass the rest on, and then we handle each symbol as it comes in. So what that looks like is we're going to slice the string with the slice string node. We're just going to look at the first symbol, okay? And this is going to be our current command. Then what we're going to do is we're going to slice the string starting at 1, and we're going to go until the end. And an easy way to guarantee that is there's a string length node. We can take this and plug that in like that, and then that will just get the rest of our string, and then we pass it through. So now every iteration of the repeat zone, our string is getting smaller and smaller. We're processing one character at a time, and this is the character that we're processing. So if you think about it, what we need to do this particular example is we just need the capital F, we need the minus sign, we need the plus sign. So what exactly are those? Well, we can check here, if the string is equal to F, then we know that the current command is that capital F. So what we do is we move forward, remember? So moving forward, we draw a line and then we advance the position. And here we can plug in our position and our direction. So we need to create a line, and I'm going to do a mesh line. Our count can just be 2, and we start at our position and we move in the offset is the direction, and that's all that we need. And then what we'll do is we'll run this through a switch. When this is true, then we can add this in. So what we're gonna do is just put a join geometry here. Oops. And this will join nothing if that's false, if this is not F, and it will join this mesh line if it's true. And that'll be a pattern that we repeat over and over again. The other thing we need to do if this is true is we need to advance the position up in the direction of the, in the direction really. So what we're gonna do is add something to the position, and we're just, again, going to add our direction. One other thing we can do just to make this a little bit easier in the future is, in addition to our angle, because we're going to want to do some scaling, and it's easy to just add a length in here. And now that we have our length, we can take this offset here and actually just scale it by our length. And then plug that in here and plug that in here. And then we can have a parameter to adjust the overall size of everything. So again, we only want to add this to the position if this is true. So we're going to use another switch statement, this time a vector switch. If this is true, then we use this added one, and if it's not, then we just pass through the existing position. And for right now, we're just going to pass through the direction. So if we look at this, right now, we need our length to be 1, I believe. Yes, here it is. Okay, so what we've done is we've moved up 1. And you see if I go into our premise, if I make this 2 Fs in a row, then we should be, oh, we need to make the iterations 2. And then it's processing the first 2 commands, which is FF, so it's moving up 2. Or here, it's just F. Okay, so that's working. Now the next thing is, because you see I had to manually change that, the iterations there, I can get rid of the need to do that manually and do the same string length node. Oops, I'll just copy this. And we plug this into the iterations, and then it will just process every single instruction, and you see it keeps going up. But we haven't implemented turning yet, so that's our next step. So what I like to do is take all of this and just group it all up. To handle this, I'm just gonna call this our F group, our F rule. And that takes this length on the outside. I'll join those up, join those, or frame those. Okay, now we need to implement our minus sign. And so what our minus sign does is it just changes the direction. So if this, again, is equal to our minus sign, then what we do is we take our direction and we are going to rotate it. And we're going to rotate it around one of the axes. So if we want to look at it in this view, to move to the right, we're going to be rotating it around the x-axis. So there's our x-axis, and then here we're going to be taking our angle, and we need this to be converted to radians because that's what it expects here. And that should do it. And then again, we're going to take a switch statement. This should be in false. This one should be in true, and it should be here. And so that's how we turn to the right. Okay. Now we see, if we look at it from the correct side here, we have exactly that, the square that we saw before. Now let's try upping the iterations here. Well, it's not doing quite what we wanted because we haven't yet implemented the plus sign, which is just the same thing as this, but we're gonna do it in the other direction. So we can just take this angle and multiply it by -1. And we can just chain these together, because if this doesn't trigger, then it will just pass through the same way. And then we just, we need to copy this. We'll name this plus, and then we'll change this to plus. And there we go. We have our curve, our kind of fractal curve. And I think in the book it said for each iteration you reduce the length by a factor of 4. So I can keep reducing by a factor of 4. And there we go. We have our basic L system working with a fractal curve. I'm going to save this file. Okay, that's pretty cool. That's all it takes to do these 2D fractal curves. But the next thing that you're probably interested in, if you're doing L systems, is not just these curves, but actually these branching structures that look kind of like plants or trees. So there's a number of examples right here. And all we need to add to do these examples is something called branching. And so you see the new characters are this open and close bracket symbols. And so what that means is when you open the bracket, you need to save the current state, which means the position and the direction. And then when you hit this symbol, then you restore the state back to what it was. And we need to be able to nest those so we can do this as many nested branches and everything as we want. So what we need to do is implement branching. And all we need for that is we just need some new symbols. I'll just type them out here for now. Then we need a way to save our state and restore the state, because right now we're just tracking the state on every iteration, but how do we save it and restore it later? Well, I found the right way to do this, I think, is by having a new input, and I'll just call it branch here. And what we're going to do is we're going to create a point, and we're going to store named attributes, and these will be vectors. And one of them will be called position, which actually I think is the same as this, but the point is you can do this with anything. You can store as many things as you want like this, and they all are kind of like storing a state onto a stack. So we plug the position into our position and the direction into our direction. So this will take our current position in our current direction, and it will save it onto this point. And then we just need to pass that into the branch. But we're going to do the same switch trick. So we're going to take our branch and we're going to join geometry, and we're very specifically going to put this new one on the top, because that will, if you put it on the top, then it assigns this new point to index 0. So that way we can always keep track of the most recent branch that we encountered. Will always be index 0. And we pass that through here. And the switch should go here. And I'm going to bundle these all up into a group. So now we can save a branch, but how do we restore the branch? Well, what we're going to do is we're going to take our branch and we're going to separate geometry. And what we need is when the index is equal to 0. So that will just separate out the index 0th point, which we had our attributes on. And then what we can do is we can very easily sample index, and we know it will be index 0. And we get our vector, we can get our named attributes. One will be position, and the other one will be our direction. Okay, and those are our two attributes right there, just like that. And then we just pass these out, but again, only if this evaluates to true. So we're going to take two new vector switches, plug them both into true, and use the result of our switch, of our equals right here. And false, our direction, we'll just take the most recent direction one we have, and this will take the most recent position. We plug this into position, we plug this into direction. And now, I'm going to back this up, we can try out one of those examples. So one of the branching examples that they give in the book is we start it with a premise of just f, just moving forward. And whenever we see an f, we replace it with f, then we open a branch, we do a plus f, we close a branch, we do an f again, then we open another branch, we do a minus f, close that branch, and then we do another f. Now you already see the branching going on right here, right? But our angle shouldn't be 90 degrees anymore, it should be 25.7 degrees. and it's kind of doing the branching. Something is not right. Oh, I know what it is. I'm not remembering to, we need to do the switch again. So if we encounter this branch, then we take those off, but then we need to still pass through the rest of the branch. That's what we need. And the result goes here, and there we go. Now we have a plant-looking thing with branching. So this is one of the examples in the book. The other example that I really like, this is one of my favorites in the whole book. It's with an angle of 22.5, and again we start with F, but our rule is to replace F with two F's, then a minus sign, branch minus F, plus F, close branch, then a plus, open branch, plus F, minus F, close branch. And this one I think looks really cool. It looks kind of like a seaweed or something like that in the ocean. So I really like this one. But if you notice, it's very flat. So now we need to think about how do we do it in 3D. And it's actually not that hard. So we'll start with something a little bit simpler. But to do 3D, basically all we need is two more commands to rotate in the other axes. So right now we're just rotating around this axis, but then we need to be able to change things along the other two axes. We need our two other rotation commands, or sets of rotation commands. And so those are our pitch and roll. So this is called turning, and I can name that. Turn, and then I can do pitch and roll. And in order to do that, we need to have one more vector here, and this is called the up vector. And that will also go into our repeat zone. And so our up vector, right now, the way that you think of it is to turn left and right, we're rotating around the x-axis. We're going forward this way. And our up vector is, if you imagine you're in a little car driving up here, and you're turning left and right, then up would actually be here. So up would be the x-axis. At least to start, and we can change this later. So what that means is we actually have to go into here, and instead of rotating around that, always that same axis, we're going to be rotating around the up vector. And here too. So our axis is actually our up vector. And that will just be here. And I'll just pass that through, and you see nothing really changed now because we're not using the rotations on the up vector. But we're gonna sort of copy this template. And then we're going to name these, the equivalent of the minus and plus are these symbols here. And so, instead of rotating around that same axis, we are trying to rotate around a different axis. And so this is to pitch and yaw. Pitch and yaw means to go kind of up and down as you're going forward, right? So as we start, that would be along the y-axis, but later as we're rotating around, it won't always be the y-axis. So what this will end up being is instead of the up vector, it's actually going to be the third vector that we haven't explicitly tracked, which is the cross product of the up vector and the going forward vector. Same here. We're going to take our cross product, and that gives us kind of our third axis. So now we can experiment a little bit with what if I put in this symbol. Well, now we're going in 3D, right? It doesn't look that cool yet, but it is in 3D. You see? So that's the beginnings of our venture into 3D. And then this is called not turn, it's called pitch. And then we just have one more to do. And that one is called yaw. And yaw means we're basically rotating the up vector. And so if you yaw, then you're rotating the up vector around the direction that you're traveling in. And so for this one, we're going to again copy this template. We are going to be outputting our up vector because we're changing our up vector. So this will be up. And instead of rotating our direction, we're going to be rotating our up vector around the direction that we're going in. And then we change that switch. Oh, and this needs to be that symbol. I got that right. We need to change this symbol. And then yet again, our axis will be our direction, and we're rotating the up vector, and the up vector goes in here, and then this is actually up. And then the last thing we need to do is handle this in our states. And so we just need to store one more, store one more attribute. And this will be called up. So this is how you can store whatever you need in the state. You can store all kinds of things. And then we store our up vector right here. And then when we get the state out, we're going to pull in one more sample index 0, but we're going to be getting our up. And this will be up. And that is just here. And then we pass in our up vector. And we can start playing with those right now. And we can say, for example, instead of minus, let's put in this. So now we're doing a yaw command. And then maybe in this one, we're going to yaw in the other direction, and now we have two different ways of doing 3D rotations now. And that's basically how we do 3D. So there's a cool example in the book, just like this, and we're going to be able to do most of this right now with what we already have. So our starting premise, it will be actually something called A. So it doesn't have to be a command, you see. It can actually be just any symbol you want, as long as the symbols turn into commands later. And we're going to need 3 rules for this. So I am going to duplicate our rules. So I have 3 of them. Then going back over here, it's quite simple to add more rules. We literally just have to drop in more of these and then just wire these up. And so we're starting with A, and then we're going to, you see, if we don't need this to be an F, this can be an A. This is what they call node rewriting in the book, but it's not really that important, I think. And then whenever we see an A, we will replace the A with okay, so each one of those branches is just going forward. It's doing a leaf, but we don't have a leaf yet, and then it's adding another A. So you see it's starting to kind of climb out like that. The next rule is every time we see an F, we will replace that with an S, and then 1, 2, 3, 4, 5 of those, and another F. And every time we see an S, we will replace that with an F and an L. Okay, what I had done wrong was I passed my up into my direction here. So make sure that up goes into up. And now you see we start to have this branching structure, right? And if I increase the iterations, you see it's kind of reaching out. You can play with the angle. And it's kind of making looks a little bit like a bush. But what we need is we need leaves, right? So we see this L. Well, what does that mean? In the book, he uses a totally different type of L system that does polygons to make leaves. But what we can do is we can say up here, we can do whatever things we want, right? Because we're in control of this L system. We say whenever there's an L, what I'm going to do is I'm going to create a point at my current position. Oh, wrong one. I'm going to create a point at my current position, and then I'm going to instance a leaf just on that point. And again, I will do the same switch thing that we did, and I'm going to take this geometry, join it, just like that. And so we need a leaf to instance. The other thing to keep in mind is we should align the rotation. So we want our leaf to be going, he explains it in the book. The diagram is pretty easy to understand. I think it was page 119 maybe. Here. So you need to have your leaf oriented so that your heading, so that's what we call the forward direction vector is going this way, and our up vector is pointing up. So we can do that quite easily with the align Euler to vector nodes. So we want, let's say our z should be aligned in up. And then we put another one of these and say maybe our x, oops, don't do that. Our x should be aligned in our forward direction. Okay, so now it should be aligned, and now we just need something to instance. And we could start with a small icosphere. So you see we're making these tiny little icospheres everywhere there should be a leaf. but let's say we can squish it down so it's flat. Maybe scale it out in the direction that we're going, and then move it over. Oh, this should be something kind of like that. There. 0.02 maybe. So now each one of these is a leaf, and it's going in the right direction. What I like to do to make it look a little bit more believable is now we can just do a random value for the rotation, say just something sort of like this. But we need an ID, because right now these will always be 0 because we're only doing one of them, and I find a very good ID is just the current string length, because that changes with every iteration, and then we get some random variation. And then we can just apply a very simple material. I will call this leaf. And you know, for now we just make it kind of a green color. And then all we need is to do some simple curve stuff. So at the end of this, we can put a merge by distance to make all of these into single line segments instead of a bunch of little line segments. And what I like to do is a mesh to curve. We can set our curve radius, and we can do some stuff with the spline parameter or whatever. Oh, we want to actually separate components here. We only want to be doing this to the mesh. We don't want it to be done to the instances. And then at the end, we will join the instances back up. We do a curve to mesh, and we can just put in a curved circle. We don't need that much resolution. And we can set a material. I can just create a new material right here. So this part should all be pretty much the same as other things that you've done in the past. Just kind of a brown color. There we go. We have a simple plant. And with a little bit of tweaking on the materials and just adding in a little bit more random variation, I was able to do stuff like this. So this is the same plant that we just created, but what I did is I made these little red berries, and said every time there's a leaf, there's actually a chance that it will be a red berry instead of a leaf. Very simple materials. See, our leaf texture is only slightly more complicated than the one that we were just doing. And our stem texture is, again, something very similar, but looks pretty good just on its own. And if you do a couple more examples, I can show you, for example, this grass. If I show you the L system for the grass, it's the same L system nodes that we were just working on. It's all very simple. Here's another grass example, and this is just the same leaf texture. Here's a third example. See, these L systems are all very simple. But if I take a plane and I scatter it all in the plane, and I just added a little rock there just a minute ago, it actually looks pretty decent with very little geometry, and I can keep creating more grasses and more plants and scattering them around, and you can see what it does. And I'll show you an example render right here, and that's it.